Hi everybody, welcome to DevNet Create. I'm your host Ian Hawkins. I'm one of the engineering managers in Australia and New Zealand, and we're going to be hosting you for the next section of this content that you'll be getting to enjoy. Now, I lead a couple of parts of the business, so I look after the engineering world for data centre and Queensland, but I'm also a strong advocate for our developer community in Australia and New Zealand. Now, when it comes to certifications, a lot of my team across the country have actually started with the DevNet certifications, and that's been a great way of formalising some skill sets and showing the growth in our industry in Cisco, the programmability world. Now, I also run the Cisco Live section for the DevNet Zone. So if you're ever at one of our Cisco Live events and want to learn about programming or do a lot more about the programming world, then go to the DevNet Zone at Cisco Live. Now, one of the other things that I like to do is chase Debbie around the world, and I'm sure you've all seen Debbie the robot. And here he is when he came to Australia last year in Melbourne. And he's one of my great supporters too. So he and I share a lot of tweets in the world, and he's one of my favourite characters to work with. And one of the other major characters in my life that I like to work with is Mike Petrinovich, which is actually now going to talk to you around how to program and automate within the audit process. So the idea is for us to create ways to make our lives easier. And Mike's come up with a way to make his life easier and hopefully provide outcomes to other businesses in more effective ways. So Mike, good morning, over to you.
Really well, thanks, Ian. I'm really excited to be here, and I can't wait to share my use case with everyone here for DevNet Create. So what exactly am I going to be talking about is how we can actually make use of the programmability aspects of ACI to help with maintenance windows and the auditing process. So just quickly about me, I've been with Cisco for over close to 14 years, focused on data center, cloud, and programmability, and I call myself a hybrid engineer because I have the infrastructure expertise and a double CCIE, but as well combining that together with my DevNet skill set, so DevNet Associate, DevNet Specialist as well, and I'm really proud to be part of the DevNet 500. And what I'm also excited to share about with you is, some of the tools and resources that I really like to make use of. So definitely dcloud.cisco.com, and basically anything data center that's in the sandbox environment. And what I'm really getting into lately is around the multi-domain sandbox. But what I'm really excited to share with you is this particular use case where I was needing to work with a customer, right? I had this massive challenge in terms of a large ACI multi-pod environment. It was approximately over 100 switches across 6 different data centers, and everything was going smoothly. However, due to some unforeseen circumstances across the entire data center as a whole, all vendors needed to perform auditing of the health of the overall infrastructure. So, the team from Cisco Services was actually engaged in order to perform this health assessment for the customer. And, first and foremost, they kind of started off, and what they were doing was very much a manual process where, they needed to go and execute show commands, copy and paste that into a spreadsheet, and then effectively do manual analysis of all of that data that they were capturing. And now for each one of these checks as part of the audit would take about 3 to 4 hours. In total, each audit that they needed to run was taking about 15 to 20 hours. So as you can see, that's very time consuming and still very much prone to human error. So due to my experience in programming and the team knew this, they actually approached me to say, could we codify a lot of that auditing process to really help out the team? So what I actually put together was, a couple of Python scripts in order to extract all of this information that they needed via APIs, collate it, perform analysis on it, and effectively was able to do the exact same tasks that they were doing across those 100 switches, across those 6 different environments in under 10 seconds, right? So that's a massive time saving, especially from a level of effort perspective. And then furthermore, in terms of some of the maintenance window activities where they really wanted to understand what was happening both before and after, and was there any movement in terms of their applications or their endpoint, because they didn't want to have any unexpected interruptions to the application as a result of some infrastructure changes. So just some quick sample output. Again, this is not from the actual customer environment, but from my lab, obviously for privacy reasons. But again, you can see the script, and this is just a small subset of it, but was able to provide in a user-friendly way in terms of, what are the VXLAN IDs, if they're matching or not, what are the tenants and VRFs, what are created, where are they deployed, as well as their endpoints or their applications from an information perspective. So again, it was really about, efficiencies in the auditing process coming down from 15 to 20 hours to under 10 seconds. And then similarly, in terms of some of these maintenance window activities that they were really interested in, I was able to provide them with an easy-to-use script that will do a snapshot before they actually perform their activities in the maintenance window, and then they take another snapshot after. And then we were able to then compare and contrast and actually identify any differences in the results, right? Were there any endpoints with movements? Were there some endpoints or applications only in the first capture, meaning they disappeared as a result of the maintenance window activities? Or similarly, are there some endpoints only in the second capture, which means they appear only after the maintenance window activities? So again, just a real quick snapshot in terms of, some of the power that you can get from codifying, that logic and how it can actually help the overall business. Right, so obviously in terms of automating the audits, look, it allowed for insights and analytics in terms of the deployed infrastructure, which means the developers got real-time detection of potential fabric issues, allowing them to be more proactive in terms of, how they needed to go about their day-to-day job and allowing them to take preemptive steps to not impact any applications. Right, in terms of being able to automate the checks, both pre and post maintenance, we were able to assure the performance and the availability of the applications, so they weren't impacted by some infrastructure changes. Obviously, the infrastructure team was able to troubleshoot faster or potentially prove their innocence much quicker. And then lastly, what this meant for the end user was a positive user experience throughout. So ultimately, it was really about having various teams work together in order to save time, minimize human error, all by enabling custom tools, workflows, and processes to overall help the business. So just quickly, again, here's some of my resources that I feel that would be of use, my LinkedIn and GitHub. And most importantly, just thank you very much for watching. I hope you enjoy the rest of DevNet Create. And back over to you, Ian.
Thanks, Mike. Appreciate that. It's a great way of using automation to build in those efficiencies, and saves me an awful lot of overtime to pay to you while you're being more efficient. So thank you. Another DC team member of mine is Richard, and he's going to show us how to use infrastructure as a code. So Richard, good morning. Over to you.
Thank you, Ian. Thanks for the opportunity to present here today at DevNet Create. My presentation's on using infrastructure as code with DCNM, or Data Center Network Manager. A little bit about myself. I'm obviously been with Cisco for 10 years now, and I see myself as being able to, again, much like Mike said before, be able to join my skills as a CCIE and my coding expertise to be able to improve and simplify sort of complex operations. Now, my presentation today is on infrastructure as code with DCNM. If you haven't come across infrastructure as code, it's really trying to treat network configuration as software code, particularly around code versioning, history of changes, and the ability to even roll back to previous versions of that code. You can also build infrastructure as code for networking into a similar continuous integration or continuous development CI/CD pipeline as you would use for software development, where you can make a change, test that change, approve that change using some internal process, and then push that change into a main branch, basically a production set of network configuration. The basic example workflow I'm going to go through today, it's certainly not the be-all and end-all of infrastructure as code, but it covers the key parts. First of all, you would have your network configuration in some form, and today we're going to be using Ansible to control that. And that itself is part of a GitHub repository for effectively software configuration, version management. You effectively download the latest version of the network configuration, you make whatever changes you want, and then we push that change back into the GitHub repository. Within GitHub, we have effectively a webhook, effectively a notification capability, where it notifies a separate program called Jenkins, which is part of our CI/CD pipeline, that a change has been made to the network configuration. Jenkins will then go and build a particular build environment that we've documented and designed, in this case built using a Docker container, And that will go and grab the latest Ansible configuration from that GitHub repository and then execute that script. Now, part of that Jenkins workflow, we could add various testing mechanisms and approval mechanisms, but this example, it just goes straight and pushes that configuration straight to DCNM. DCNM will again accepts that configuration from Ansible and then converts that into actual NXOS CLI configuration through a set of templates and pushes that configuration down to the actual Nexus 9000 switches. Once that's done, that's not the end of it. DCNM sort of manages that configuration from that point onwards. And the key benefit here is that it provides continuous assurance and a full audit trail of what's actually happened in the network, who made changes in the network, and if there's been any configuration drift over time. And that's done basically automatically, not necessarily whenever we have to run that Ansible script. So you get that permanent continuous assurance. So this is an example Ansible playbook that is stored within the GitHub repository. And we're using the official Ansible modules for DCNM as effectively the engine that we're using to drive the configuration changes. Now we store effectively a set of files in here, one of which is the one I'm showing here, the set of tasks that we use to configure the network. Particularly here, I'm adding a layer 3 VRF routing table and adding layer 3 SVI interfaces, VLAN interfaces across my switches as well. And so my tasks I've shown here are effectively to build some custom dictionaries for each task, effectively how we build the instruction set we pass into Ansible. And I also have in here a separate inventory file that I use to define where my DCNM server is and how I connect to that in terms of credentials. The main information is stored within this network parameters file. And this is a totally custom built file. I built this myself, and it's really to try and create this simplified intent for the fabric in terms of here's a group of servers and switches and ports that represent the ports connected to a particular VMware cluster, which VRFs I want to find, and what VLAN networks I want to find. Now you might see here that none of this involves any CLI configuration. It's purely the bare minimum intent that we need to configure the network. Also stored alongside these configuration files is my Docker file. And this is effectively a file that defines how I want to build my environment that I actually execute these scripts within. Now, this Docker file, it's pretty straightforward. It just basically defines I want to use the latest version of Ubuntu Linux. I want to install on that some Python, and then I want to install, finally, right at the end, I want to go and download the latest DCNM Ansible modules from the Ansible Galaxy collection. We push all these files into a GitHub repository. This is simply showing our internal GitHub repository. And in a production and real-world environment, we would look to clone this or to at least branch these files when we want to make changes, then push those changes back when we're finished with them and merge them into the main branch after some form of review. As part of that GitHub repository, I have a webhook defined to my Jenkins server. And so every time I make a push into that repository, that gets updated. And Jenkins knows about it and takes over. Now within Jenkins, we have a particular project defined that basically says, like for this example, where my code is, where the GitHub is, when I want to build that code, what triggers that GitHub build environment to go and grab and run those, execute those scripts. Where to build them, which is this customized Docker container, and obviously this effectively a set of scripts to explain what needs to be run and how we run that. And that's that last section there on the bottom right. Effectively, that's running the Ansible playbook. So very quickly, as we run through the console output, when this task gets triggered, Jenkins goes and grabs the latest code from Git. Part of that GitHub repository is that Docker file. It grabs that Docker file and executes that and builds up that Docker environment, including grabbing the latest Ansible and DCNM modules. We then, again, mount a directory containing that downloaded GitHub repository scripts, and then Ansible takes over and executes those scripts. It goes and connects to the DCNM server through its API, and then runs those particular tasks. So in our environment here, we have identified effectively a set of switches towards a VMware cluster and a set of switch ports. We're going to add VRFs and we're going to add various network configurations to that. So adding VLANs to trunks, adding a layer 3 SVI interface at the top of rack switches. Sort of day 2 tasks that would be very common for a normal VMware environment. And DCNM, that looks a bit like this. We get a list of VRFs and a list of networks defined. Now, these are defined as policies within DCNM, and each of these DCNM policies is associated to a particular switch or switches. From these policies, we have an associated template, and that is used to generate the actual CLI configuration. We can go into that in much more detail in another time. The CLI configuration at the end looks a bit like this. This is the configuration, actual CLI configuration that gets pushed to the switches themselves, so the VRFs and for the networks. Now, once we've done all this, the real key here is really how we can keep this running for day 2 and how we can adapt this for any changes in the future. So for example, we wanted to add a new host to the cluster. From a networking point of view, that's just really, I just want to add the same VLANs to this new interface, these new trunk interfaces towards this new server. And that's as simple as just adding that interfaces to that existing inventory group. If I want to extend it to another pair of switches, so I've got my clusters now on 2 different racks, then I would simply add 2 new definitions of the switches to that group and run the same scripts again. It would go off and connect to all switches and confirm that push all the configuration across all of those top of rack switches. If we wanted to add a new VRF, that's as simple as adding another VRF definition to the list, as shown here, Ansible demo VRF4. And if I want to add a new VLAN, which is probably the more common thing, a new port group on a VMware cluster, we'd simply add that to the networks section there at the bottom. All right, well, thank you very much. Thank you for giving me the opportunity to present today, and I'll pass you back to you, Ian. Thank you.
Thanks for that, Richard. As you can see, our engineers in Cisco have had to come to terms with using programming to build in workflows and create ways to be more effective and provide more functionality with our customers. So we're going to continue with the theme, and we're going to hand over to Abhishek, and he's going to talk about bulk claims services in Intersite. Over to you, Abhishek, and welcome.
Thank you, Ian, and thank you everyone for joining. This session is about bulk claiming Cisco servers in Cisco Intersite using Ansible and Python. My name is Abhishek Nadola, and I'm a customer success specialist for data center here in Cisco. Prior to joining Cisco, I was also a developer, so I'm always keen and passionate about how automation can solve real life problems and challenges. And speaking of challenges, one challenge we are going to address today is how we can bulk claim servers into Cisco Intersite using automation. So if you guys are familiar with the current process of the claim process of a server in Cisco Intersite, basically it's still a little bit manual in terms of you have to go into each server management IP and basically get the device ID and claim code, and then you have to go into Cisco Intersite and claim those devices. So for customers where they need to onboard 100 to 200 servers at one time, it still takes some time for them to onboard the servers. Now with Cisco, with this particular script, what customers and partners can actually benefit is basically the onboarding time of servers into Cisco Intersite is drastically reduced. So what it means for the operations team is once the servers are onboarded, basically they can start leveraging those deep insights and visibility into their data center compute portfolio through Cisco Intersite. And what it means for the application teams means they can take those preemptive steps to avoid application outages. So let's look at the script and how you go about executing the script. Basically, this script is also available on the GitHub repository. We'll send you this, we'll be posting this as a takeaway slide, so you will have more detailed instructions on how you go about running the script and setting up your environment. But just from the logical workflow, there are 4 high-level steps on how you go about setting up the environment to running the script. The first is basically you need to set up the environment, so make sure you have the relevant libraries, packages installed, for example, Python, Ansible, Git. The second step is basically to get the files itself from the GitHub repository. Once those files you have downloaded into your local workstation, also you need to make sure you have the relevant API key for your Intersite account. So you need to generate that API key going into the Cisco Intersite and generate the key from there. The third step is basically you need to modify the necessary files as per your environment. So one of the files you need to modify is basically the inventory file. So this file basically would have all the IP address details, all the credential details as per your environment, which you need to modify. Once it's done, basically you're good to go. And the fourth step is basically executing the Ansible playbook. So let's see the script in action, what it does, and how do you go about claiming the servers. So in my demo, I have a quick demo. Basically, what I want to show you here is today I'll be claiming 3 servers at a time. So I have 2 standalone servers and 1 UCS domain. I'll be claiming in my Cisco Intersight portal. So this is my Cisco Intersight portal. And basically, the script which I'll be running today is the Ansible playbook. So as you see, I'm running the Ansible playbook and mentioning out the inventory file, which consists all my details of my server and the login credentials. So once I run this script, it might take some time to run the script, depending upon how many servers I'm claiming. So in the meantime, when the script is running, I just wanted to show you the code itself. So basically, this is the main YAML file. It consists all the details, for example, your Intersight API parameter keys, and also it consists of all the default parameters. So for example, in my lab, I'm not putting any proxy server. I'm not having any proxy server. So by default, it will not it will apply the default proxy settings. And then it calls the claim device.python file. Basically, the claim device Python file does all the heavy lifting in terms of connecting to your appropriate device connector, whether it is a UCS B series, Hyperflex, or a IMC supervisor, which is your rack mount server. Once it connects, it appropriately configures the device connector in the correct settings. For example, if it's a read-only mode or allow access all control mode, and then basically going about claiming these devices into Cisco Intersight. So, and this is my inventory file. Again, a very simple inventory file. I have my 3 servers. I have mentioned the IP addresses, the device type, whether it's a rack mount server or a UCS B series server domain, and all my credentials. So let's look at the script itself. It should have been executed. Yes, it has. And you can see the status has changed. So let's verify the script and see if the device has been claimed into Cisco Intersight. So what I'll do is basically verify it from 2 ends, one from the server itself, and I might need to do a refresh quickly, and run from the Intersight portal itself. So I'll take this serial number and then as you can see, the device has been claimed now, and then again from the operations teams and the applications team, they can start getting those benefits into the rich telemetry of Cisco Intersight. Just quickly verifying the same thing from the device connector as well. From the rack server should show the status of being connected. Right, so as you see, and that should be the same case for other servers as well. So as you see, it's very simple script to use, and you can leverage this script basically from the GitHub repository posted here. And also I have put out other useful resources. Again, this is just a particular use case and a challenge we are trying to solve. But if you have another use cases suited to your environment, I'll highly recommend please refer the API docs. And also there is this great lab resource available in developer.cisco.com, which you can use. Just wanted to quickly mention, if you want to go one more step ahead, there is also, we have a good repository, how you can voice manage your Intersight portal to Alexa, which basically what the script does is basically it executes, the function is enable new voice commands over Alexa, and the Lambda function then triggers a script, a Python script running on your S3 storage. If you're So those are basically how it works. I'll really recommend to check it out if you are really geeky. But yeah, thanks, and enjoy your DevNet Create sessions, and happy coding.
Thanks, Abby, for that. That's a good example of how all of the engineering team at Cisco have had to adopt some programmability skills to be able to showcase how we can use our technology through the world of programming to increase functionality and efficiencies. So on that note, I'd like to thank you for all of the time you spent with us in Australia and New Zealand so far. There's a lot more content to go in the first virtual Cisco DevNet Create event, and please stay on, still enjoy the rest of the day, But from Australia and New Zealand, thank you for your time and goodbye.